Section 3. Introduction to VEXnet. The unit objectives. The students will be able to explain what the specific components of the VEXnet system can do and how they are used to control the robot. The students will be able to set up their own microcontroller to function in both autonomous and drive control modes. The students will be able to use the VEXnet system to successfully control their robot in a classroom challenge. VEX Cortex Microcontroller. The VEX Cortex microcontroller coordinates the flow of all information and power on the robot. All other electronic system components, motors, sensors, and etc., interface with the Cortex microcontroller. The microcontroller is the brain of the VEX robot. The microcontroller has an array of ports: 10 motor ports, 8 standard 3-wire motor ports or servo ports, and 2 2-wire ports, 1 I2C used for advanced sensors, 2 UART fast serial ports for use of the VEX LCD display, 8 high-resolution analog inputs and 12 fast digital I/O that can be used as interrupts for sensors, and battery ports for the VEX 7.2-volt robot battery and 9-volt backup battery. VEXnet joystick. Although many robots are designed to operate autonomously, there are often situations where manual control of a robot is necessary. The VEXnet joystick allows a human operator to control a robot in real time using the innovative VEXnet wireless link. The joystick has 2-axis analog joysticks, 4 trigger buttons, and 2 button directional pads. It also has an accelerometer that provides XY tilts outputs. There's a picture of what it looks like. VEXnet wireless link. The implementation of the wireless link through the microcontroller is designed to eliminate the need for any knowledge of IP addresses, MAC addresses, security settings, and IP protocols. Just turn it on and it automatically connects to the correct joystick. Setting up the VEXnet wireless link. Refer to the Cortex microcontroller and VEXnet joystick user guide to set up the VEXnet wireless link. Pair the VEX Cortex microcontroller and VEXnet joystick. This procedure is detailed in Step 1 of the user guide. Wiring and configuring a VEX robot, plugging in and controlling motors. The VEX Clawbot has 4 motors which power the 2 sides of the drivetrain, a claw motor and an arm motor. This default code is programmed to map the controls of the VEXnet joystick directly to the motor ports of the Cortex microcontroller. When the following motors are plugged into the following ports or the Cortex microcontroller, the default code allows for the following controls. Plugging in and controlling motors. So the left motor drive, when plugged into motor port 1, is the left joystick. The claw motor, when plugged into motor port 6, is the left shoulder buttons. The arm motor, when plugged into motor port 7, is the right shoulder buttons. And the right motor drive, when plugged into motor port 10, is controlled by the right joystick. Plug the left drive motor directly into motor port 1 on the Cortex microcontroller. Make sure the red wire is on the left slide. Plug the right drive motor directly into motor port 10 on the Cortex microcontroller. Make sure the red wire is on the left side. Plug the claw motor into a motor controller 29, making sure that the colors of the wires match up. Plug the other end of the motor controller 29 into the Cortex microcontroller. This is a keyed connection, so there is only one way to plug this wire in. Plug the arm motor into motor controller 29, making sure that the controllers of the wires match up. Plug the other end of the motor controller 29 into the Cortex microcontroller. For more details on wiring the VEX Clawbot, see page 16 of the Clawbot assembly instructions. Installing batteries and VEXnet keys. Plug a 7.2-volt VEX battery into the 7.2-volt battery port on the front of the Cortex microcontroller, next to the on-off switch. This is a keyed connection, so there is only one way to plug this wire in. Plug a VEXnet key into the Cortex microcontroller into the USB slot on the top of the Cortex microcontroller. Using a Phillips head screwdriver or VEX 332 Allen wrench, depending on which version of the joystick is used, remove the screws that attach the battery cover to the VEXnet joystick. Remove the battery cover. Install 6 identical AAA batteries into the VEXnet joystick. Do not mix different types of batteries. Reinstall the battery cover by inserting the 2 tabs of the battery cover along the back edge to aid in installation, and then reattach the screws that were removed earlier. Plug a VEXnet key to the VEXnet joystick into the USB slot above the battery cover. Getting started. The Clawbot by default is set to operate in tank drive mode. This means that the left wheels and the right wheels are controlled independently by individual joysticks. To make the robot go forward, push up on both joysticks. To make the robot go backward, push back on both joysticks. To make the robot turn left, push the right joystick up and the left joystick back. And to make the robot turn right, push the left joystick up and the right joystick back. Answer the following questions in your engineering notebook. Explain how the microprocessor functions, explain how the VEXnet works, and explain how you would use the joysticks in conjunction with the VEXnet system to pick up and score the bottles or cans in a classroom challenge.